There,
All right. Good morning, all. Thank you for joining us. My name is Sarah Husky with 3C Ren. I work out of the County of San Luis Obispo, and welcome to the first course in our 2022 Energy Code series. Today, we have Andy Pease and Jennifer Rennick from Imbalance Green Consulting to walk us through how to comply with the new 2022 Energy Code for single-family residential projects. Before we get into the course, I'll just be rolling through a couple slides. We have a large group with us this morning, so we ask that everyone just make sure they're on mute. And if you would like to verbally participate, please raise your hand and we will call on you to unmute yourself. If you have a more in-depth question, though, we do ask that you hold those until the Q&A at the end of the course. But we also encourage you to participate and ask questions through the chat box as well. Okay, next slide. So a little bit about us. We have the Tri-County Regional Energy Network, also known as 3C Ren. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Ren is funded by ratepayer dollars, which are collected through the public goods charge found on our utility bills. We currently offer 3 programs. The Energy Code Connect program serves building professionals by offering Title 24 support for residential and commercial projects. Within the Energy Code Connect program, we have our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for Title 24 related questions. We also have our building performance training, which serves building professionals such as architects, engineers, contractors by offering technical and soft skill trainings related to building science principles, high performance buildings, marketing, and communication techniques. And we have our home energy savings program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through incentives and rebates. So you might see a few 3C Ren staff members on the training today. If you see anyone with this background, feel free to chat with them directly with any questions you may have. And with that, I'll pass things over to Andy and Jennifer.
awesome. Thanks so much, Sarah. It's really great to be here with Jennifer Rennick. We're both architects, and Jennifer is a certified energy analyst. I'm a lead accredited professional. I'll be doing the kind of the introductory components and the overview and baseline information. And then when it gets difficult, then I hand it over to Jennifer. We do have, we'll follow the chat, and Sarah, can folks unmute themselves, or they have to ask to be unmuted?
They can unmute themselves, yeah.
Okay, awesome. So if by some chance we're not seeing you and you have something pressing, we are allowing plenty of time though at the end to make sure you have time for questions. So the new energy code took effect on January 1st. So today's learning objectives, we're going to talk about the organizational changes in the code, the big picture goals of the California Energy Commission, and the key updates throughout all of the sections of the energy code. You do get learning units for this. The health, safety, welfare are pending. We're going to apply and resubmit, because we know for our architecture community that's helpful, and these certainly qualify for that. We just need to make sure we have the paperwork caught up. This is a multi-part series, and so today we're doing single family. The rest of it we have spaced out over the next few months. So existing buildings, additions and alterations coming up next month, then accessory dwelling units, multifamily projects. We're slipping in Cal Green, so not obviously the energy code, but related, and 3C Ren has purview in that code section as well. And then finally, non-residential. If you are anxious to get this information sooner, we did offer these courses, present these courses in the fall. And so 3C Ren recorded those, and they're available on demand. And you can always just reach out if you have questions, and at the end, we'll talk a little bit more about Code Coach and your access to that program. So here's our sequencing for today about talking about the reorganization. We'll also end with kind of a high level view of additions and alterations, but otherwise we know that's a big area of design for our professional community, so it gets its own section next month. All right, so triennial cycle, just to kind of get everybody on the same page, the California Energy Commission has a very robust public involvement process to be able to develop the updates to the energy code and the energy standards. And what is impressive about this effort is that they must demonstrate that all of their upgrades are cost effective. So over the life of the building, all of the changes need to be able to pay for it themselves with the energy savings over the life of the building. And so that you will see some of the changes vary by climate zone, because the climates are going to have different responses and requirements depending on those needs. So the big picture goals for this update is moving toward electrification, as has been the trend for our last couple of cycles. This one does even more so. So encouraging heat pump technology, both for space heating, space cooling, we've always been doing that, and water heating. So that's a big effort, learning curve for our industry. Electric ready requirements for single family homes, expanding the PV systems and battery storage, you'll see is new for us, and strengthening ventilation standards as our buildings are tightening up and we're cycling our heating and cooling systems less frequently. We're trying to decouple the thermal comfort with the ventilation to make sure we have healthy buildings. And nearly 70% of California's electricity buildings, homes and businesses use nearly 70% of California's electricity and responsible for a quarter of California's greenhouse gas emissions. That's just for the operations, right? We are focusing on the 3C REN Tri-County region. So that's climate zones 4, 5, 6, 9, and 16. We'll touch on the others. And if you're working in other climate zones, just ask and be sure to know where you are on the map for your projects. Main thing is the new code is already in effect. So anytime you're applying for your permit, you can get the documents available online. There's a link, and forgot to say at the beginning, you will get a PDF of the slides at the end. And 3C REN has some great resources. They have a library with a whole all the standards, and Energy Code Coach is a totally free service where you go and send an email question. You can even call, and it goes to a clearinghouse, and then energy professionals will be able to respond. And so it could be a reference point. It's for design professionals, jurisdictions, contractors, anyone who wants to use it. So if you feel like you're getting stuck, you need more detail, reach out to that free resource. All right, Energy Code reorganization. So the current, or now past code, had three sections, the all building sections, but then high-rise residential, non-residential, hotels, motels, all of that was shoved into one section, and you had low-rise residential. The new code keeps those sections, but then adds this multifamily buildings section. So that got pulled out of the that first cluster. So that's the new section. Another way to look at it in terms of how we read the code is that it was low-rise residential and not low-rise. They did this nicely, though, is that they kept the subchapter sections. So those are all still there, and then they've added this multifamily. So single family is our focus for today. So the high level changes is, yay, we have a new source, a new method for looking at our metrics. and it's called Energy Design Rating, which we have been using, but the new one is the source energy, because again, we're trying to look at greenhouse gas emissions. There's baseline space conditioning and water heating updates that include heat pumps now. Before, you were kind of almost fighting against ourselves when you were trying to go all electric. There's also changes we'll touch on about attic system insulation, kitchen range hood, airflow rates, ventilation duct sizing, and as we said, electric and battery ready. And so a lot of these changes are affecting energy efficiency. Things that were optional have become part of mandatory requirements. Again, making sure we're all on the same page, because we're going to be using these terms, and it may have been a while, or for some folks who are newer to this code section. So we had the mandatory requirements. Those are the energy efficiency measures that are applicable to all projects. Then we have the prescriptive component package. If we're thinking about the recipe, this is, you're following that recipe exactly. So you can have windows up to this size, insulation must be a minimum of this level, efficiency for your equipment at that level, etc. It's important to know that even though most folks are probably going to do a performance model, the important thing about that prescriptive component package is that it is the baseline for your allowed energy budget. So the performance method, you're the cook in the kitchen who's kind of freewheeling it a little bit, because you're trading components. You need more window area, but you know that you can be more efficient with your equipment and still fit within your budget. So we call prescriptive, or the prescriptive is often called the checklist approach, and performance method energy modeling. So a couple more terms here. We have time-dependent valuation. That's the cost of energy, and that takes into account the time of use, that there are peak periods. And then we have the Energy Design Rating 2. That's the performance method metric introduced under the 2019 code. There's an efficiency part and a solar part, and you need to pass both of those. And now we also have one that's this EDR1, which is about source energy, and it's a proxy for determining the impact of carbon emissions. So additions and alterations are still using TDV, but new construction, you're going to be using these the energy design ratings. So,
Andy,
yeah.
there was just a question in the chat asking what the climate description is for climate zone 5.
Climate description, like, I'm not sure.
Yeah,
I can circle back with them on that question. I kind of need more information to know where to send them for what they might be looking for.
sounds good. Thanks.
Yeah. And is that North County here, or is that San Luis Obispo?
San Luis Obispo Climate Zone 5, but I mean, just in general, if you're looking for like design days, heating, cooling,
Oh, right.
or just the descriptions themselves within the code, within the California Energy Code, this Title 24 Part 6 documentation we're looking at, there's a portion of that I could direct you to afterwards that will tell you about your climate zones. And there's a website you can go to too, that the CEC's put up that helps you find where your project's located on the climate zone map and a description.
Great, thank you. So as we're looking at kind of all these ways to think about energy, so site energy, the energy that is being used on the site itself, and that takes into account the renewable energy. And then otherwise, when you're pulling from the grid, it wants to know, like, what's the carbon emissions of your of power source that your grid tied to. So as we increase our renewable energy into the grid and have cleaner grid, then that's reducing the carbon. So the source energy, the important part here is that the source energy EDR is a new proxy for carbon. And that'll continue to get some clarity. But if you just think about it from a logic standpoint, the more renewable energy you can use and battery to help kind of level that off, the lower your carbon footprint is. And so that's going to help you with compliance on the code. Lower energy use is going to help you helpful. And then as we clean up our carbon, our grid overall. So we have these three numbers that we're going to be tracking. This EDR1 source energy, it does impact envelope, indoor air quality, HVAC, domestic hot water, and unregulated loads. And then same for the EDR2, that's looking at the efficiency. And then the EDR2 is the total, so you get an efficient building, and then you add the solar and the battery. Sorry, I know it's not super user-friendly in that way, but we're going through it because you're going to get a Title 24 report, and it has 3 numbers on it, and you have to pass all 3 in order to get the magic complies. So proposed design, and then standard design, the proposed design, you need to have the low carbon, the efficiency, and the right number of solar panels. Okay. I think that's the main ones that I wanted to cover. I'll turn it over to Jennifer. Do you have anything to add on the prior, or are you ready to jump in?
I'm ready to jump in.
Woohoo!
Okay, I'm gonna take you through some of the mandatory measures for the residential new construction. And we are going to touch very, very lightly on addition alterations, just as to say, here's a couple highlights. Please come to the next course that we're offering. But today we're going to primarily focus on new construction, single family residential, which does include duplexes. And anything beyond a duplex, 2 units, you would then be directed to go to those brand new multifamily sections. And for the single family section, that's fine, you can click ahead. For our single family mandatory measures, in general, for the single family, not a lot of changes are in the code that have to do with the envelope. So if you're familiar with the 2019 energy code, the 2022 code is going to be pretty similar. So that's some good news for a lot of the architects, designers out there when it comes to the envelope. But there are a few things to be aware of, and I'm going to point those out. I'm going to point out those big changes to be aware of. So for climate zone, and CZ is short for climate zone. So climate zone 4, which would be North County, San Luis Obispo, like Atascadero. It also goes all the way up up to San Jose. And then climate zones 8 through 16, and those would be like down in the Santa Barbara area. There are some new insulation. It's a requirement that now the insulation is either above the roof deck or below the roof deck. And a ceiling insulation, that's now what you need when you have a roof deck in newly constructed attic systems. This is for when you're putting your ducts in the attic. So the exception is if you have duct work for your heating cooling system that is below that insulated ceiling. There are some kind of cleanup with the energy code where the folks who are working on the energy code are trying to get better alignment and not duplicate efforts on the plumbing code and the mechanical code. So 2 examples of that: insulation for piping and for the tanks for hot water is that they've, out of the energy code, they've taken out all those additional requirements for like tank insulation, extra insulation around the tank. And they've had a greater alignment with what the plumbing code is saying you need for the insulation on the plumbing of the hot water pipes. And basically what's unchanged is that you still have to insulate all the hot water pipes very well. And you, of course, if you've got a pipe going through a wood framing member or something else like that where you can't insulate there, that's okay. That piece doesn't have to be insulated. And then, of course, unchanged is if your plumbing is within an assembly where it's fully covered with plenty of insulation, those areas are considered insulated when they're completely buried. And then what that looks like now, just kind of FYI, go to the next slide, Andy, is now our energy code references the plumbing code. And I put an excerpt here just so you could have it handy in case you're reading one code but not reading the other. And the main takeaway here is to keep in mind that for our small pipe sizes under 2 inches that we usually see in domestic hot water situations, that insulation thickness around your pipe has to be the same as the diameter. So what that means is, like, for a 1/2 inch pipe, that's going to come out to about an R3 to R4 worth of insulation. And so it's a quality insulation product. Okay, next slide. For the residential lighting, kind of a similar concept, greater alignment with the electric code. So they've now, in the energy code, they reference the electric code when it comes to certain clearances and insulation distance and insulation requirements around the housing, the junction box, the transformers, all that with your recessed lighting fixture. And the other 2 changes you might notice is that they just simplified what qualifies as kind of an efficient lighting source with LED lighting, and made it easier for those of us who dig into the code and need to look at that specifically for lighting. It's a little simpler to understand what qualifies and what doesn't qualify. Okay, next slide. So when the California Energy Code references the California Electric Code, in this case, they're just saying, basically, I think for us as architects or lighting engineers, lighting designers, most of the time, you're going to want to spec out a lighting fixture that is IC rated or insulation cover rated, or type IC it's called. But if you don't, you need to know that that fixture is going to have some way to be fireproofed with a cover, and there's going to have to be 3-inch clearances around the housing, the wiring, and anything that is part of the fixture that can get warm. There's been some changes, kind of significant changes now, for the requirements for indoor air quality or fresh air ventilation. And what this part of the code did in the mandatory measures is they at least removed the parts that specifically were addressing multifamily dwellings. So that got put into the new section. And then this section is going to deal specifically for the single family or the duplexes. But the concept is still the same, in that fresh air needs to come into the building or to the home. And that's going to be in alignment with ASHRAE 62.2 for fresh air. And those systems need to be field verified. So there's been some updated or added language, however, on how you can do it. And I'm going to run through some of those big picture changes. That's part of the mandatory measures and part of the prescriptive measures. And that has a lot to do with fans and duct sizing and what we're allowed to do for fresh air ventilation. So some folks choose to install a heating and cooling equipment that can also pull in their fresh air requirement for their home. You can do it, but the main premise from the old code and this code is still the same, is that you can't run that fan continuously as a way to provide fresh air, because it will be greatly oversized for the amount of outside air that you need if you're running it through a large fan through all the ductwork you need for your heating and cooling system. So they've just clarified how you can do it, which includes damper controls and variable ventilation controls, and it has to be proven that that's an operation. For our kitchens and bathrooms, we still need local exhaust. That's still a requirement. What they've updated is to give some clarification that you can use what's called energy heat recovery or energy ventilation, energy recovery ventilation. It's a form of balanced ventilation, and there's certain efficiency with how much watts per CFM or cubic feet per minute the air is drawing through that system. But that can be a permissible way of bringing in fresh outside air. It does not have to be an exhaust only fan system. It can also be a supply side system. There are still, I would just want to point out that a lot of folks, or at least, in one of our other courses, there was a question where people were concerned that if they have to have fresh air ventilation and they have to have this fan running all the time to bring in that outside air, what do we do in California when it comes times that there's fire or other outdoor air pollution that's extreme? And I just want to point out that this part of the code hasn't changed and it's still applicable, is that everything needs to be labeled. And yes, the homeowner needs to have the ability to turn these fans on and off so that they can control that indoor air quality when the outdoor air pollution quality is very high or the air quality is very poor.
Jennifer,
Yeah.
there was a question that came in. So if there's an ERV system, a local bath exhaust fan is optional. How does that work in terms of overall ventilation versus bathroom exhaust?
Yes, there is some clarification in there in the code. And I have been involved with projects that the ERV HRV system was whole house system, and it was able and designed to take care of the bathroom exhaust. You as a homeowner may want a small localized bath exhaust to make sure that you can add a boost of exhaust ventilation. Also, some of the ERVs, HRVs, you have to be careful on which one you choose, because some of them specifically say they're not designed for high moisture areas. So if you're using the small ones that are meant for like spot ERV or spot HRV ventilation, a lot of those wouldn't be appropriate for bathrooms, laundry rooms, and sometimes your kitchens. So you have to be strategic, but what the energy code is saying is you have to ventilate, you have to meet these certain requirements, and if you use ERVs, they have to have a certain efficiency.
Great, thanks. And there's a question about kitchen hoods, but that'll come up here.
Yes, so when it comes to the kitchen hoods, we do have new tables that are in this mandatory part of the code, and something new that's coming up with kitchen hoods is that they are being rated for what's called capture efficiency. Not all manufacturers have their hoods rated yet, but a lot of them are starting to get rated. And you can, you're going to look at that capture efficiency of that hood, and it's going to give you an idea of how much of the emissions coming off of your cooking are going to go outdoors and how much still gets kind of circulated back, or, you know, by default don't get captured and go into the space. And so this is an illustration of a kitchen hood that has 55% CE, or 55% capture efficiency. And what you will notice is that in these new tables, the CEC, with support from research that was done by the EPA and other entities, they said, yes, the emissions coming off that natural gas range are higher. There's more pollution in it than coming off an electric range. So the gas range needs to have higher capture efficiency or higher CFM in order to be effective, in order to have good air quality in the unit. And what they've also discovered is that very small, like apartments or studios that are less than 750 square feet, for example, the smaller it is, the higher the concentration of pollution, because it can't dilute out into a big volume of air. So you'll notice that as the dwelling unit gets smaller in floor area and presumably volume, then the efficiency of the hood goes higher. And when you switch from electric to gas, it goes even higher still. So in this example of a capture efficiency, about 55%, which is not unusual, and you might notice this in your own kitchen. If the hood doesn't come out fully over the stove, only part way, you turn stuff on, the front burners never seem to get caught in that hood. Okay, so that's what this is an example of, and that would now only be allowable or permissible in dwelling units that are at least 750 square feet and bigger, for an electric range only. And I just recently switched from my gas, but I didn't swap out the hood, to an induction electric range, and the air quality is noticeably improved. It really is. My kids notice it, I notice it, so.
And there was a question, I assume that whether it's electric resistance or induction, either way, that's electric in terms of this hood. Table.
Correct.
Yeah.
Now, related to this, and this includes the ductwork too, with kitchen and baths, but related to this is that that ductwork needs to be field tested by the installer to show that it's really getting the draw that it's supposed to be getting. And in lieu of field testing that hood with either a flow hood equipment or flow grid equipment, in lieu of that, you can follow a prescriptive ventilation system for duct sizing, which is also now in the code. And, for architects, this is maybe a good thing to look at when you're just starting to lay out things in your kitchen, especially, if the quarters are tight, or if the kitchen is internal to the house in some way. How are you going to run that ductwork from that exhaust hood to the outdoors? And this will come in more in play for multifamily if you all are doing apartments, but we'll hit on that when we do the multifamily projects, because it's going to be kind of a big deal, maybe in some situations, to keep the total duct length below 25 feet and no more than 3 elbows and there's other requirements as well. Or you have someone come out and do the duct test, this kind of testing. And this equipment here runs about a couple $1,000 for the installer or a HERS person to purchase in order to start field testing or do the prescriptive.
In the testing one, is that necessarily a HERS rater that would need to be qualified and sign off on an inspection form of some kind?
The installer can do the field testing on this, but then there'll be, and I haven't dug into what that paperwork looks like.
But it doesn't have to be a HERS rater for this one.
No, but it could be.
They're out there anyway.
Mhm.
Thanks.
Okay, another mandatory measure is to get the homes kind of ready for battery storage. Battery storage is not required under this energy code, but to get things in place so that it's easy to allow homeowners in the future to have battery storage is what's new to the code. And so the intent really is to make it easier for households' electric generation and storage system to be able to offset like evening electric grid energy use, and also to address resiliency in case the power goes out. So case in point, if, you know, for the resiliency part of it, part of this new code is to say that there's going to be a minimum of 4 branch circuits, and they shall be identified, and they would feed the refrigerator, at least 1 light circuit near the primary egress exit entrance, and at least 1 sleeping room receptacle outlet. Presumably that's, you know, something you can have your phone and other things there where you need, where you're sleeping, and of course light for egress, and then refrigerator. Everybody's food goes bad. So those would be the minimum. And then the panel size now would have a minimum bus bar rating of 225 amps. So it was 200, now it's 225. And there's some other requirements on how you would set up that sub panel for the branch circuits, and having a place for a future transfer switch with the installed raceways. So this battery ready part is going to impact some of the work that now the electricians are going to be doing on your new construction residential projects.
Do you want to just kind of that key concept, I think is so important in terms of resiliency, right?
Right, right. Yeah, so yeah. So key concept again is the intent behind this is to increase that household's electric generation and storage system robustness to be able to offset electrical grid use for grid stability, and also add resiliency for the homeowners in case that power grid goes down, which it will at some point. Hopefully not very often, but it does. I don't know about any of you, but we lucked out in that last big storm. Our power didn't go out, but I know there was about 5,000 customers just north of me up here in North County, Atascadero, whose power all went out last weekend.
Yeah.
So having if they had a battery or something like that, it'd be helpful. And then part of that mandatory measures to tag back on to electric ready is now they've included furnaces, cooktops, and dryers. In other words, if you install a furnace that is gas, a cooktop that is gas, dryer that is gas, next to those areas where those appliances go in, you would have the electrical circuits installed that's ready to be used by a future homeowner, or if, you know, if they swap out their appliances to electric. So for the gas cooktop, for example, not just an electrical outlet there, but you need one that's enough that can do 50 amps for a future like induction or high electric cooktop. And same with the dryers, same with the furnaces. And we already have that requirement for water heaters. And the key concept behind this one is that it's to remove the known cost barriers that prevent households from transitioning to energy efficient electric appliances like heat pumps. So there's a lot of folks who might want to do a heat pump water heater. It's one thing to buy the heat pump water heater, and then it's another thing to then have to hire an electrician to come out and run new circuitry, find space on their electric panel, and have it set up so that that heat pump can be set in. So with electric ready new construction, you put that infrastructure in from the get-go when it's cost effective to do so. Okay, we're gonna hit on these highlights and then we'll be wrapping up. We're doing good here. Okay, when it comes to the performance method or computer modeling, there's a key takeaway in that the 2022 Energy Code is trying to support move to all electric because we've got a cleaner electric energy grid. It is better from a carbon reduction standpoint to go all electric when we have a clean electric energy grid. And how we do that is through how we do it efficiently and cost effectively is through heat pump technology. So if you put a heat pump in your energy model in the project, your heat pump is going to be your baseline. That may not sound like a big deal to many of you, but in my world, doing energy modeling, that's a big deal. It makes it easier to have these projects comply and work. And it's going to help you all with that carbon proxy, EDR1 that we talked about. You want to say anything about these, Andy?
Well, I just wanted to, just because folks may not be as familiar with the specific systems that we're looking at, and I can't remember now if you go into the details, but in terms of a split system for the water heater, I don't know if you just want to kind of walk through real quick.
Yeah, that's a really good point. It's a good point. Yes, we do. Yes, not everybody is familiar with what the heat pumps are and what that means exactly. We do have other courses that specifically address the heat pumps. But if you're unfamiliar with that word or term, a heat pump is the way we pull energy out of the air and we transfer that energy into another medium like air or water. So the mechanism that works for our refrigerator is a heat pump, and our air conditioner equipment, those condensing units outdoors on our air conditioners, those are heat pumps. And so we've taken that same technology, we just call them heat pumps instead of giving them a different name, and they come in compact sizes that can be used to heat and cool your house. They're known as split system because you've got an outdoor condensing unit, and then through refrigerant piping, that heat transfer happens to the indoor unit, which moves air around in the house to distribute the heating or the air conditioning, the cooling. And then there's bigger versions of that work with ducted systems so that you can connect them to big air handlers for centralized duct systems. And that same technology can be used to heat water instead of the air. And these also come in integrated systems where the heat pump sits on top of the hot water tank, or it could be a split system like that Sandco 2, where the outdoor unit, the small one, looks like a suitcase, is outdoors, and then the hot water tank is indoors.
Thank you.
Yeah, and yeah, absolutely. And what is key, and I'm pointing this out, is Andy alluded to some of these things are climate zone specific. And that's because of the cost effectiveness studies that were done, and because of the climate zones in their extreme temperature ranges. And so that impacts cost effectiveness. And so when you do a prescriptive approach, like that recipe checklist sort of approach for climate zones 3, 4, 13, and 14, heat pump space heating is the baseline. That's what's required. And this is a photo taken from one of our colleagues' projects, and it just shows two types of outdoor condenser heat pumps. One that looks really typical on the right-hand side, which goes to a ducted system. You'd also see that like with your air conditioner, and then a mini split was added. And that one, yeah, is on the left. And then the piping comes out the side of that and goes through the wall and into the house, into a small indoor unit. And I just made a note here that, you know, a lot of folks ask, you know, because of this new requirement, can I still have like a small heater, space heater, like right at my bathroom, or can I still have that electric resistance pad that goes under the tile in my bathroom floor? Yes, that part of the code hasn't changed. You can still have it. It can be small and on a timer.
Hey, Jennifer, before we get too far away from the electric ready, there was a question that came up. Shouldn't the high voltage connection to be outside for the gas furnace replacement? Since the interior air handlers would replace the furnace, usually take regular voltage. I guess it's just the question of where to put the electrical capacity for a replacement for a new, if you put in a gas furnace, what would that look like? So would you put it outside, I guess, in order to be able to be electric ready for a furnace?
You may need to. So depending on how, you know, the furnace, where it's located, how it's set up, that may make the most sense. Let's say you had a furnace set up in the garage, and that furnace, if it was not near an exterior wall, and so case in point, I had a client who did this, took out the old furnace and air handler, which was located in the back of their garage. And nowhere near that would have been a good place to put the heat pump. And so if that had, it was a remodel, but if it had been new construction and that was the setup, I would look at that in terms of, yes, where would it make the most sense for that outdoor condensing unit to go relative to now where we've put the furnace. And if it turns out they were back to back, okay, that's great. Then, but if not, you have to really think about that. But the idea is that you set that electric infrastructure in place already. With the other appliances, it's assumed that if you have a gas dryer there, you take the gas dryer out, you're going to put electric dryer there. So it needs to be within 3 feet of that appliance. Same with the cooktop, and same same with the water heater.
Great, thank you. And there are a couple other specific questions coming in about heat pumps, but I think we can address those as a group at the end and share some of those ideas.
Yeah. And then interestingly, with this climate zone, again, based on this cost effectiveness stuff, for those same climate zones, 3, 4, 13, and 14, if you do the condensing unit, the heat pumps then gas is allowable. And that gas water heater still has to meet the minimum energy requirements and be of a certain size. But you do one, then yes, the other, just for those climate zones. And so it is a little nuanced. I point this out because a lot of us are in climate zones 3 and 4. So when you're looking at what that baseline is, you're going to want to go into the prescriptive tables and look at it. But I also know from playing around with the software that the energy code is not precluding you from using gas appliances for anything you want to. It's just that I've noticed so far with the certain projects and their other parameters and trade-offs that sometimes it was just easier to go to the heat pump and I got to jump on the compliance margin and got to jump on the carbon margin. But I could have played around with it and traded off other energy saving features or other carbon reduction features in order to use the gas appliance. So you're going to have to work it out. We're still all kind of new in the code to figure out where all the little tipping points are for a particular residential design. In our climate zones, most of the folks want to mitigate away from doing exterior continuous insulation on the walls. That's still a part of the code. So if you don't want to do that and you want to do gas appliances, I had a project that wanted to go that way. That's going to be trickier. That is going to be harder. I'm just going to tell you straight up. Something has to give. Right? So in that case, okay, for new construction, and in this case, it does apply to the additions. For all the climate zones, you can install the heat pump water heater. And if you show that in your project in performance method, if you put one in your model, that becomes the baseline. And it's the prescriptive allowable pathway for your water heater in all the climate zones. What's new is that an instantaneous electric water heater with point of use distribution, and that point of use distribution is key, is allowable for dwelling units or additions that are 500 square feet or less. So this really is to address like the small additions, ADUs, tiny houses, those things, realizing that for something as small as 500 square feet, it was not as cost effective and sometimes quite problematic to get an heat pump water heater for that size of dwelling. However, the electric on demand, the instantaneous type, seems like such a logical solution. But under prior code cycles, you couldn't use that type of water heater. So they've made this allowable now when you meet these special requirements of 500 square feet or less and point of use distribution. And there's what a bunch of them look like. They kind of look like the on-demand gas units, only there's no gas and no flue that has to be dealt with. So they're quite cost effective. On the next slide, I'm going to show you what that point of use distribution looks like and what that means. So if you do choose to use it, the point of use distribution is saying you need to put that water heater right near the fixtures that are going to be using the hot water. And these hot water pipes do need to be insulated. And there is a table that isn't part of the code that tells you how long of pipe you can have based on the nominal diameter of the pipe size. So in this particular example, if you had one of the Stiebel Eltron water heaters, they have a 3/4 inch line coming out of the heater. But what you would want to do is very quickly set up a manifold right after that 3/4 inch line, set up the manifold and do a parallel pipe run so that you only have like the 1/2 inch pipe going to your shower, which is only going to be a few feet. And then you would do, you know, like 3/8 inch off of that manifold running to the sink faucet, and maybe your kitchen sink might just be on the backside of that little bathroom in a compact, efficient, you know, setup. And then these are additive. So let's say we had only a couple of feet of the 1/2 inch. So make it easy. You could say, well, I have 5 feet of 1/2 inch. I could have 7.5 feet of 3/8 inch, but you're allowed to kind of make add those together proportionately to meet these requirements. But really what you want to do is get down to the smaller pipe size right away and do like a parallel piping. Okay. For some of the climate zones, 8 through 14, ventilation cooling with a whole house fan is a prescriptive requirement. So this is largely unchanged. But again, thinking about the tiny houses and small dwellings, so 500 square feet or less, you don't have to do this. And that's kind of the change. But otherwise, larger homes, bigger than 500 square feet, new construction, whole house fan for cooling is required. And I don't know, you guys can ask me if there's questions on that, if folks aren't familiar with what that looks like, depending on your climate zone. That's different than a fresh air ventilation fan. Those things are big. The idea is you open the windows and you turn that on and you evacuate all the hot air out of your house. Now, kind of some change here on the PV systems, but again, the change mostly was to make it, there's one change to make it more cost effective, but the other change is they tried to clarify the language on what is a solar access roof area to kind of better explain that to people, because key concept still is that for solar PV, new construction, you follow the formula or the equation, or you kind of max out the roof's solar area, and whichever one is smaller was the one you have to do. But in most of our projects, we've noticed that almost all the projects would have enough roof area to accommodate the required PV system. However, there are those projects out there in more densely populated areas where you could imagine a single family home going up 3 stories and having a small roof up at the top of that dwelling. So their house may come up with one number, but the roof area is small, so they may end up really needing to calculate the solar access roof area so that they could, you know, max out the roof. And that's how much PV they'd have to install. This is here for you, basically kind of reference and reminder. A lot of this is helpful. This is from the code. I think that if you have a project that's in a situation where your roof area is really smaller than your PV system needed for that formula, then you're going to want to dig in a little deeper on how this is calculated, and you'll need some assistance most likely, because the solar access is determined by, for example, if you're a steep roof, you have to figure out how much of that roof would be exposed to the sun and then how much of the roof would not be exposed to the sun from man-made or natural obstructions that are external to the dwelling, like trees or hills, adjacent structures. But for low sloped roofs, it's all obstructions, including those that are part of the structure itself, like a parapet, or in some case, you might actually have an internal elevator and that top part of the elevator comes up and that would shade the roof. So then you're going to do a different calculation to determine what your solar accessible roof area is. And then no matter what, you still need to comply with Title 24, Chapter 9, the fire code. And there are some requirements that, for example, that area can't be less than 80 square feet, and it has to at least have a dimension of 5 feet so that a panel can fit there. In this particular example, there was over 300 square feet of space. So for that size of the house, they were going to have plenty of space anyway. And then the other thing is you would follow the formula for the PV system size. And the only change on this formula from last code cycle to this code cycle is when it comes to the number of dwelling units in this formula, it's either going to be a 1 for single family or a 2 for duplexes. Otherwise, the formula is largely the same. And this is an example of a duplex. Calculated, it's the whole conditioned floor area of both the units together, climate zone 5, plug in the numbers, and we end up with a kilowatt PV system nominal nameplate size of 2.79 kilowatts. And if that number had come out to less than 1.8 kilowatts, the PV wouldn't have been required. So that's the new part of the code, is no PV required if that PV size is less than 1.8 kilowatt DC. So cost effectiveness kind of comes in there. And then you get a bonus PV reduction of 25% if you would install it with a 7.5 kilowatt battery. And here's adjustment factors, A and B, for that formula for your reference. It's also in the code. So the red box are the numbers we pulled and plugged into that formula. And then for the designers and architects out there, I've got another slide that just shows how you can get an idea of how many panels or how much roof area that would take. And this system here, assuming the same little duplex, if I wanted to figure out how many of these panels I would need, about how much area it would take, you could look up the specs on a solar panel. And I just used this Solar World 340 watt solar panel for reference. And the formula is fairly straightforward. You take that kilowatts, you multiply it times 1,000 to get your watts. And then the panel itself is rated at 340. So take that, divide it by 340, and I get 8.2 panels. So you can't have a fraction of a panel, so call it 9 panels. And this is as a designer to get an idea of what kind of space and layout you need. So I've got 9 panels, and I can look at that panel and look at its dimensions and calculate, based on those dimensions. Either I can lay the panels out themselves, or I could say, okay, that's 20.8 square feet roughly per panel, 99 of them. So I need about 188 square feet of clear free roof area. And in this case, it was only about 16% of that floor area, or that roof area. So and that's pretty consistent with a lot of the solar ready things you may be familiar with, where they want you to save, have 15% of your roof area available for solar panels.
Jennifer, a
Yeah.
question came up about for a duplex, if there's separate meters for the duplex, electric meters, do you calculate each one individually? Or because they're connected and under one permit, you calculate them together?
Well, if they're on separate meters and they're functioning independently, completely independently, I guess it's a question of if it's really a single family duplex or is it a townhome situation? So you got to kind of look at that. But in the Title 24 side of it, doing your calculations, if I have that project and it's a duplex and it's one property owner and maybe there's the main panel and the sub panel and the 1 meter, I'm calculating all together and I'm giving one Title 24 report under the single family residential code that's a duplex. And then if I'm in a situation where I've got, and technically that project was, I just used it as an example of a duplex that you could have. Technically, that development was a multifamily development. And it would have been, you know, technically that would just be one piece of a part of a multifamily project calculation.
Right.
So you
Okay.
got to kind of
And-
figure out, is it townhomes that just happen to be 2 townhomes together as a duplex?
Right, or it could be stacked, maybe.
Or stacked? Yeah.
Then it's a different situation. Okay, thanks. And there's some great question coming up about cost effectiveness of solar with the new net energy metering, but we'll save that to the end because that is a bigger
Right.
question.
But also just keep in mind too, that if your project is so small, and we're seeing that where it came up is this push to get more affordable housing, denser housing, accessory dwelling units being allowable and, you know, not allowed to preclude them. So you've got these smaller, a lot of times smaller homes. Yeah, it wasn't cost effective and a lot of those small ones would have that PV system size that was less than the 1.8 kilowatt, you know, nominal size. So yeah, you wouldn't have to go to all those expense to do it. And then, yeah, the whole net metering thing, okay, that's a different question. Yeah, we'll get to that. Okay, on the additions and alterations, I'm going to give you a couple of real quick highlights in general and just kind of big picture overview. And we're going to talk more about this in our other presentation coming, another course or training coming up. And there's a lot of existing building stock in California that are existing homes. So the additions alterations section is important in terms of the energy code and bringing those projects up to a higher efficiency, depending on less energy in general to keep them heated, cooled, electrified with fresh air. And so it's important that these projects are addressed, but it's nuanced because of climate zone and just because of certain size constraints and because when it comes to additions and remodels or alterations, not everything is cost effective across the board. So that's why we're going to talk about another presentation. But kind of big picture, there's not that EDR score for the additions and alterations. It's still just, it's a TDV, % better than, pass, don't pass, required Title 24. And then there's some new sections, J, LMN, so referring to the vented attics, the ceiling insulation and mechanical indoor air quality ventilation and exterior doors. And I'm just gonna give you a highlight on a couple of these. So for climate zones 1 through 4 and 8 through 16, this one's kind of an interesting one. Altered ceilings shall be insulated to R49. And no, it's not a typo, and R49, yes, is higher than the prescriptive requirements for new construction. So the thinking behind that is in alterations. if you have a chance to get access to that attic, to that ceiling, now's the time to insulate, and insulate as best as you can, because insulation is relatively cheap compared to doing anything else to walls, windows, and the rest of the structure. So this is shown to be cost effective. So R49 is a requirement. And also update on really spelling out, what do you do with those existing fixtures, light fixtures in the recessed ceiling? Do you replace them? Do you cover them? How do you cover them? There's language about that. And that the altered ceilings must be air sealed, which wasn't specifically addressed under the old code. New construction says that a building shall be sealed for leaks. It's not tested, it's hard to know, but now they've added that language for the altered buildings. And then probably the kind of new section, relatively robust section, is all the alterations that come up when you have ventilation for the indoor air quality or your fresh outside air systems. And there's language about balanced ventilation with heat recovery. And that image there on the bottom just gives you an idea of what a diffuser box, the size of a manifold, and 3-inch ducts. So they're really quite small when you do a dedicated balanced ventilation system. And then there's new language here or clarifying language that just says if you're going to have new or replace that ventilation system, what's required if you hit that 75% threshold on new equipment. And similar to what we went over in the section above for kitchen exhaust, bathroom exhaust, and the indoor air quality is going to be similar. But I encourage you to take the class on the additions and alterations, because it is some of it's a little bit duplicated, but some of it, I mean, in terms of this particular section, is similar to what we covered, but it's also nuanced in when do you have to do it, when do you not have to do it, what size of a unit requires it, or, in terms of floor area, and what floor areas don't trigger these requirements.
Hey, Jennifer, on the air sealing in the attic, you just need to air seal, but it's not tested, right?
Right. We don't
You
have
can't
any
just test. Yeah.
Yeah. So a lot of these are like through visual inspection, but we don't, as part of the HERS required QII, quality indoor insulation requirements, there is a visual inspection for that air sealing. So it depends on those requirements being triggered, but now with the additions and the alterations section of the code, they're specifically addressing it and putting a language in there to bring that up. But under new construction, we're supposed to be already doing all of it. And when I say they don't test it, as in they're not requiring blower door tests where they seal up your house and put a special fan in like the front door and pressurize the house to test how much it leaks. Yeah, that hasn't, that's not
you can't do
required
that
yet.
in isolation. Yeah.
Yeah.
We were wondering a couple years ago, like, oh, are they going to put that in the mandatory? But no. And so that's a wrap of the sections we wanted to cover today. We're just going to have a couple slides here to wrap up some of the housekeeping, and then we'll open it up for Q&A and general discussion. So I will pitch again the Energy Code Coach. Just go to 3cren.org and navigate to Energy Code Connect, and you can sign up for updates there. You can ask your specific questions. You can call and you'll get folks who can track down your questions. So love having that.
Oh,
Um,
Andy, like that
yeah.
like the question about the climate zones, like wanting to know the more specific information on those climate zones and all that.
Right.
Actually, that would be just a perfect code coach question.
Yeah, and we're getting, I mean, they're all over the place. Hey, does this trigger, we're doing this modification. Does that trigger the code? What's allowed in this space? Residential, non-residential. Yeah, they're great questions. And Sarah, did you want to touch on upcoming classes and programs?
Yeah, thank you. So just to close out here, there are continuing education units available, both AIA and ICC. And as Andy mentioned, I'll be working to get those health safety units approved as well for this series. And coming to your inbox will be a PDF of the slides, a recording, and a survey. Please take it. It definitely helps us out. Upcoming courses, there's a list here. There's a couple in-person, that Zero Net Carbon Design in February and March will be in San Luis Obispo. And then there's a couple other virtual or Zoom courses that will be coming up too. So take a look at our website. We have a bunch that are listed. There's a lot more listed than what is just on that slide. And yeah, with that, we'll open it up for questions, and I'll go ahead and start. There was a question in the chat a little bit earlier. Is there an online website version of ASHRAE 62.2 that's available for designers to use?
Okay. Are we moving to questions now?
Yeah, we are.
Cool.
So one came into the chat and neither Sarah nor I knew the answer. So I was waiting till the end. It's 62.2. Is that available for free online as a standard, or do you have to purchase that? Or either way, is it available online?
Oh,
You
that's
know?
a good question. So Upcodes, you could try. I don't know if it's on Upcodes. Dang, I just purchased it for our office. So I don't know about that one on the free, but usually I don't know. You'll have to snoop
Yeah.
around. It's not that expensive. And if you're if you're not a practicing architect, or I don't know, even I just purchase it personally.
Yeah. Well, maybe follow up on that one.
Yeah.
And I am going to, before we get further in, because I know there was some good discussion as well, for the upcoming courses, there's that Zero Net Carbon Design course. And I just want to make sure that folks who are licensed architects are aware that there's a new requirement in order to renew your licensure. Anytime from January 1st going forward, you have to have 5 hours of continuing education that's designated Zero Net Carbon Design. So you have your 5 hours of access compliance and a new 5 hours of Zero Net Carbon Design. So there are some classes online, and then we kind of bundled this 5 units in over 2 different days, February 9th and March 9th. In San Luis Obispo, and we're starting to have conversations about offering those in Ventura and Santa Barbara counties as well. So let us know if you either register and sign up for that one, or let us know if you'd like to see it in the South County. There was also a question or discussion, and I saw Judy, if Judy's still on the call, was kind of making some commentary about the energy requirements for heat pumps for space conditioning and right sizing those. Judy, I don't know if you want to unmute, but there was some question about, hey, do you have recommendations about colder climates versus kind of our more mild climates in terms of what to look for in the heat pump in the first place? Not sure if Judy is still on. not seeing her chime in, but okay.
I was just looking at the chats just
Yeah.
now because I'm not able to talk and look at the same time. I'm not that skilled. And I just see some comments about, oh, cost effectiveness, about switching to electric. And yeah, the cost effectiveness we're talking about, today would be new construction, really. So it's just when things are newly constructed, and there is a cost effectiveness study the state engages before they come forward with all the code requirements. And then when it comes to existing structures, like for example, with my own house, it was time for me to replace that gas range. So I replaced it, and I had a choice. Do I replace it back with gas, or do I replace it with electric? And because I do this kind of work I do, and I want to be my own guinea pig, I was like, well, I'm going to replace it with the induction cooktop and electric convection oven. And yes, that was a pain to get the electrician out there to upgrade the electric and do it. I bundled it with other stuff to make it worth their while. But that, would be a cost barrier for a lot of folks. They'd have to really want to do it. So is it cost effective in terms of energy savings between the two after I paid for all that? Probably not. Is our indoor air quality better? Yes, I was surprised. It actually is. So I'm pleasantly surprised. Was it worth it? Probably it was for me, but that's just my own, case. But in new construction, it's like the cost effectiveness comes into play too. Like some projects we have, when they go all electric, they don't have to run gas piping throughout the house. That's cost effective. But if it's a mixed fuel house, then the question becomes a little different. We do have some clients who opt for maintaining some gas in their house. So you can't use the not running gas as part of your cost-effective equation. I don't know if
Yeah,
that helps.
that's a really good point, that the not installing gas altogether makes a huge difference. I mean, not needing a meter, not needing the gas line from the street, not running the gas pipe all around the house, et cetera. So if you end up having to do gas just for the gas stove in new construction, it's a pretty big hit compared to just doing the slight upgrade to a nice induction cooktop.
Yeah, and then the other thing too comes, again, this is new construction, but the idea is something you build now that's new construction becomes someone else's addition, alteration, remodel, later on down the road. So, again, like my own personal experience, I had my gas on-demand hot water heater go out. So I got the gas on demand put in when my tank went out years ago. The best thing was the on demand. I was like, oh, wow, look, I'm so progressive. I got my on demand high efficiency unit. Okay, so that thing finally went out. And I was like, oh, God, it went out. I didn't want it to go out yet because I want to move to a heat pump water heater and really test it out, try it out. And it went out prematurely. And I was so bummed because I didn't have time to get an electrician who could come out in time for a water heater failure. And there's no way my family was not going to have hot water. So that's another reason these solar or the electric ready requirements are there, because if I had the choice, if a plumber had come to me and said, we could do a heat pump for you, or we could just replace your gas unit, I would have gone, yeah, I'll go with the heat pump. Electric would have been in place. And I wouldn't have had to deal with any gas you know, venting and all that too. It would have been a real easy swap.
A question from a little while back about the heat pumps in general. Can you provide resources for cold climate heat pumps? I have contractors who are still very suspect of their efficiency in sub-freezing temperatures, and they're working in maybe climate zone 16 where it actually is cold, and finding space for outdoor condensers in snow areas, or pulling warm air out of garages or utility rooms. I mean, we know that the undoing of the narrative about older heat pumps that weren't working in cold weather. Mike Horgan of Cairn Collaborative was in Massachusetts, was his main work. And so he's got awesome photos of heat pumps just buried in snow and the outdoor condensing units and doing just fine. But anything you want to add to that, Jennifer, in terms of, I mean, you do need to make some strategic choices, I would imagine.
Yes, and if it's like the mini splits for heating and cooling your conditioned air, that there are several brands that, like Mitsubishi and others, that go well below 0 temperatures, because even in what we consider extremely cold temperatures, cold air, there is still energy in that air. It's not absolute 0, you know, in your physics class. Think back to physics. It's not absolute 0 in that sense. So there's still incredible amount of energy in it. So then it's really coming down to the efficiency and the type of refrigerants that are used in that process that can pull the energy out of what we perceive as really cold air. And the energy's there. And then they can translate that into heat for your space. For heating your hot water with heat pumps, that's where some of it may become a little trickier, because not every heat pump water heater is going to be working in those kind of temperatures. And a lot of times you do not want your heat pump water heaters outdoors, those integrated types. You don't want them outdoors if you can help it anyway, a lot of times. But you'll see in very, very, you know, warm climates, mild climates, like there's some parts of Australia where they show their units being installed just outdoors, like on a covered porch with their washer and dryer, that kind of thing. But California is not really conducive to that.
Great. Well, we are coming up on 11 o'clock here, and so I want to honor everybody's time. Jennifer and I and Sarah will stay on for just a couple minutes because there are some specific questions that maybe folks still have. And but otherwise, thanks everyone for being here. We appreciate your time and look forward to seeing you at the next one.
Yes, like.
Thanks.
Yeah, and the person who had that question about the climate zones, they should probably just give you a link or email.
Well, it was kind of unclear. I couldn't tell. Maybe they were just asking, like, how do you determine which climate zone you're in? I mean, in some ways it's like, well, you just type in your zip code and it's, you know what I mean? I don't know if somebody is wondering,
was it Judy? Judy.
Yeah.
Okay,
it was
Judy. Oh, right.
Oh,
Now
okay.
I see it. Okay, so yeah, she'll probably just reach out to me.
Yeah. So for lingering, there was a question about non-vented conditioned attics. With insulation being required at the roof deck and the attic ceiling, are non-vented conditioned attics still an option?
Yeah, so those requirements that we were showing, those 2 ways you could do it with the insulation at the roof deck, either below it or on top of it with the attic insulation. That was for specific requirement when you have ducts in the attic and you're doing a vented attic situation. So, because of the old way folks were thinking of doing it is you just have insulation at the ceiling and you'd still have a vented attic with ducts up in the attic. And they're saying, no, if you're gonna do those ducts in the attic, you've got to have that extra layer of protection, essentially, by putting the insulation up at the top, either just below the roof deck or at the on top of the roof deck. But if you want to do performance method, computer modeling, and you want an unvented attic assembly, or you want a, you know, just keep all the insulation up to the top of the roof and have that attic be free and clear of insulation so that you can easily run ductwork, electrical, do any kind of recessed can lighting you want, recessed lighting. Yeah, that's still an option. And you just run your project doing the performance method.
All right. Is there anybody else who has a burning question that didn't get answered yet? Feel free to unmute or raise your hand. Not seeing anything more. All right, folks. Awesome. Thanks so much. And reach out if something comes up and if you have additional questions. Have a great day, everyone.
All right, thanks.
Enjoy your day, everyone.